So in this chapter, we're going to talk about a hyperbola. And first of all, let's define what do we mean by a hyperbola. A hyperbola is a set of points in a plane, the difference of whose distances from two fixed points called foci. And that difference is a constant. Now, the standard equation of a hyperbola with center at the origin is as such as given. Now, in both cases, we have c squared equal to a squared plus b squared, and also we have asymptotes related to hyperbola. So in the first figure, the one on the left, if we have a hyperbola whose center is the origin, so the asymptotes is y equal plus or minus b over a x, and otherwise with the graph on the right, we have the asymptotes as y equal plus or minus a over bx. Now, we're gonna start graphing the first one. So we have x squared over 9 minus y squared over 25 equal 1. So first of all, keep in mind we have the center is the origin. So we're gonna draw a rectangle, 3 units to the left and right of the origin and 5 units above and below the origin. Then we're gonna draw the asymptotes, which are the diagonals of the rectangle. Now, the vertices are located on 3, 0 and negative 3, 0. And the foci are located at square root of 34 left and to the right of 0. So the red points are the foci and the blue ones are the vertices. Keep in mind the equation of the asymptotes is plus or minus 5 over 3x. Another example, we need to graph x squared over 16 minus y squared over 9 equal 1. So first we're going to draw a rectangle, 4 units to the left and right of the origin and 3 units above and below the origin. Then we're going to draw the asymptotes. Keep in mind the vertices are negative 4, 0 and 4, 0. And this is my hyperbola. Now we need the foci, so c squared equals 16 plus 9, that's 25. So the foci are located at 5, 0 and negative 5, 0. Another example, we need to graph y squared over 1 minus x squared over 4 equal to 1. So first we're going to draw a rectangle, 1 unit above and below the origin and 2 units to the left and to the right of the origin. Then we're going to draw the asymptotes. Now here the vertices and the foci are on the y-axis. So these are the vertices. This is my hyperbola. Now the foci are going to be located as square root of 5 above and below the origin, and that's like 2.2 and negative 2.2. So these are the foci. And the equation of the asymptotes, the one in blue, plus or minus half of x. Now here we have to do some work before we start graphing this hyperbola. We notice that we have numerical coefficients multiplied by y squared and x squared. So we're going to divide every term by 225. Then we're going to simplify. Now we can draw a rectangle, 5 units above and below the origin and 3 units to the right and to the left of the origin. Now keep in mind here the vertices, because we're starting with y squared, so the vertices and the foci are going to be on the y-axis. So the vertices are located on 5 and -5. Now the foci are located at square root of 34 and negative square root of 34. This is the equation of the asymptotes. Now we can draw my hyperbola. We can take out the rectangle. Now we have a center other than the origin. So first we're going to start by locating the center. Keep in mind now the center is located at 2, 3. So the center, we have, this is my H and this is my K, and the center is located as HK. So this is an equation that's similar to x minus h squared over a squared minus y minus k squared over b squared equal to 1. So my h and k, so here our center is located at 2 and 3. So now the center is not the origin anymore, it's at 2 and 3. So we're going to draw a rectangle, 4 units to the left and to the right of the center and 3 units above and below the center. We're going to draw the asymptotes. We're gonna, since we're starting with x squared, so here my vertices and my foci are gonna be parallel to the x-axis. So I can take the midpoint of the segments of the widths. Now my foci are gonna be away by 5 units from that center. Now keep in mind the equation of the asymptotes. Notice, because the y is shifted and the x is shifted from the origin, so we still have b over a, but we don't have the origin anymore. So notice the y minus 3 and the x minus 2. So now let's draw the hyperbola. Now, if we're interested about the formula of the vertices, so the vertices have equation h plus or minus a, comma k, and the foci have a formula h plus or minus c, comma k. Or we can see that the vertices are a units from the center, from the coordinate of the center, and the foci are c units from the coordinates of the center. Keep in mind, this is my h and this is my k. Another example. So we have y minus k squared over a squared minus, so this formula resembles y minus k squared over a squared minus x minus h squared over b squared equal to 1. The center now is still hk, so the center now we have it located at 3, 5. Keep in mind my a is 4 and we're starting with the y, so we're gonna draw a rectangle 2 units above and below that center and 5 units to the left and to the right of the center. Now we're starting with y squared, so my vertices and my foci are gonna be parallel to the y-axis. So these are my vertices. My foci are gonna be square root of 29 away from that center. So keep in mind the center is located at 3, 5. And notice the formula of the asymptotes. So this one here is still a over b, but because the center got shifted, so we shifted the x and the y as well. This is my hyperbola. Now, we have equation for the vertices also is h, comma, k plus or minus a. And for the foci is h, comma, k plus or minus c. So notice the y coordinate got shifted. Now here, we need to draw the hyperbola by completing the square. So first of all, we're gonna group the y's and the x's, and we're gonna put the constant on the other side by adding 63 to both sides. So we added 63 to both sides to plug in the constant on the other side. We're gonna factor out the 9. Then we're gonna use the method of completing the square. So we're gonna change our binomials into trinomials that yield into perfect square. So we're gonna add 1, which is negative 2 over 2 squared. That's give me 1. And this one is negative 6 over 2 squared, which is give me 9. And this is how we added this number. So we don't have to guess. And whatever we do to one side, we do to the other side. So we added these numbers also as well on the right side. After simplification, we got the equation of the hyperbola. Notice the hyperbola has a center of 3, 1. And we draw a rectangle 2 units away above and below that center and 3 units to the right and to the left of that center. The asymptotes, the vertices and the foci are going to be parallel to the y-axis, and this is my hyperbola. And this is the equation of the asymptotes. Keep in mind, the foci are going to be 3, 1 plus square root of 13, and 3, 1 minus square root of 13. Because here we're starting with y squared, so the foci are going to have an equation of h, comma, k plus or minus c, where we have c squared equal 4 plus 9, and that's 13. So these are the foci, and the blue one, so the red points are the foci and the blue points are the vertices. Now we need to find the standard equation of a hyperbola satisfying the given condition. We have foci 0, -3, and 0, 3, and vertices 0, -1, 0, 1. So we notice the vertices. We have the y coordinate of the vertices. We have the y coordinate of the vertices. So that's where the 1 goes. So that's my a squared. So my a squared equal 1. And we're going to start, since we have all the y coordinates, so we're going to start with y squared. Now we need to find b squared. We know that c squared equal a squared plus b squared, therefore b squared equal a. And this is the standard equation. And start from the origin, because we have the x coordinate of everything we have is 0. So this is the standard equation of the hyperbola. First of all, it has center of the origin. Notice we have the vertices has x coordinate 0. So we have the center is the origin. Another example, we need to find the standard equation of a hyperbola satisfying the following. Again, we have the center is the origin, and we have a squared here, which is equal to 4. And we have the center is the origin, because now we need to find b squared. So b squared equal 32, and that's the standard equation of the hyperbola. Now it has foci -7, 0, 7, 0, and vertices -5, 5. So the vertices, we have the x coordinate of the vertices. So the equation is x squared over 25 minus y squared over b squared equal 1. So that's how the 25 came. So now, again, we still have the center as the origin, because we have one of the coordinates is all zeros. Now we need to find b squared, and we can find b squared using the formula of the foci, since we have the foci. So keep in mind where the 49 came. Therefore, this is the equation of the hyperbola. Now we have the end points of the transverse axis, and we have an asymptote. So first of all, we know the equation of the asymptotes is a plus or minus a over bx. And we know that this is my a. So first of all, we know something. Now we need to find b squared. So we're going to use proportion. So we found that b equal 3, therefore b squared equal 9. And that's the equation also of my hyperbola. Keep in mind the center is the origin, and this is the indication why the center is the origin. Now we need to find again the standard equation of the hyperbola satisfying the given condition. So now we have a focus 7, -2, vertex 6, -2, and the center is 4, -2. So we have the center is not the origin anymore. Now we know the equation of the focus is h plus c comma k, and also we know the equation of the vertex is h plus a comma k. Now notice we're taking these formulas because k is not changing. K is not changing. So we have the same k. This is my h and this is my k. Therefore my a is 2 and my c is 3. Therefore by doing calculation we can find we have the vertex is 6, -2, and we have the center as 4 and -2. So keep in mind this is my h and this is my k, and that's how it become positive 2. Another example. So now my h is not changing, so we're using the formulas. So my a now is 3 and my c is 5. Plugging them, this is my h, this is my k. Plugging them in the equation, finding b squared. Therefore, the equation of the hyperbola is as such.